This is the final video for the day on adding machines. So far I've shown a few that use gears and springs to represent numbers, so they're using rotation and translation respectively to represent numbers. Another nice way of doing adding machines is to use logic state. So these are binary adders made out of Lego, and I'm still developing this to try and get the nicest feel. So this is the first one I made. It's a simple 2-bit adder. So it's representing here, this is a 1, this is a 2, and it's off in this state, it's on in that state. So let's say, for example, I take this number here and I add a 1 to it, then that is now in a state of 1. But if I add another 1, it carries over down into the 2, so that's now representing no 1s and 1, 2 equaling 2. If I add another 1, then I've got 1, 1 and 1, 2, that's 3. So I was trying to find a nice way of building this out of Lego sort of more economically, using these flat tiles everywhere. It's a bit sort of wasteful, I felt, so then I experimented doing it just with regular bricks, so it's just running on the rough surface. In that case you can kind of see this nice carry action going through, add another 1, so that's now representing a 3. Now when you add 1 to 3, they're going to get 2 carry operations, so that's going to go 1, 2, so that's now 4. And I put little markers on here to indicate when that's in that position, that's on and that's off. It's not completely clear, but it does actually demonstrate that you're encoding state. So adding 1 more on there, now that's 4 and 1, that's 5. So that's a 3-bit adder. I got to the point of then prototyping a 4-bit adder, so it's all just trying to get the structure right. You know, this sort of repetition of these pieces and trying to make it work well. So you can put one in there, doing 1. And this one's got a nice kind of roll down there to make sure that the balls come out at the end properly. This one's also got, as is the last one actually, a reset mechanism. So say I want to bring this back to the state where they're all at 0, I just push this and it knocks them all back. So let's say those 3 are on. It's a reset. So that's really handy. So now, given that shape, I know the kind of design of the final prototype. So I've just been mocking up the actual base of that. So what will happen with this, the balls will come down here and they'll roll out. So it's nice to get these kind of things right before working on the final adder, but I think this is a pretty good solid 4-bit adder design.